Hey everyone, John Grimsmo here, bringing you another Knife Making Tuesday. So, right now I'm supposed to be running handles, but I can't because this is a digital touch probe to measure distance and offset and XY coordinates and everything. And I use this for everything. And I just broke the last tip that I had yesterday. So I can't run handles until I get this fixed. So I want to talk about the touch probe and all the cool things you can do with it, and more importantly, how to fix the broken tips, because these things are expensive to replace. Expensive. It obviously comes with one when you buy it, but replacement tips are anywhere. I think I've seen them as cheap as $50, but as expensive as $150, and I've probably broken over 10 of them, if not more like 15 over the years. Over the 3 years that I've had this and been using it. I use this thing all the time for almost every job, and I need to have it. So I started making my own replacement tips because I realized that they're fairly simple to make. So I'm going to show you guys the process of that, and I recommend it for you if you have the Tormach probe or similar probe, because they work awesome and they're super cheap. They cost like $5, and once you get the process down, you can make a whole bunch of them for not a lot of time. So let's figure it out. So basically, this plastic thing is the same as this. It's got 3 points on it. It's a kinematic thing, and it measures every time it rotates off of one of the 3 points, and it creates electrical connection between all 3, and when it breaks connection, it knows you have hit something. And I actually broke this. I was jogging it down manually, looking through a dirty window in the side, so I couldn't see what I was doing properly, and I just went too fast and too far, and it crunched it. Duh, my fault. But I realized that where the tip screws in is a metric M4 thread. So if you take metric M4 bolt, screws right in, right? And the shafts are usually carbide, I think. Carbide's good because it shatters really easily, so you break the tip, not the actual probe unit. So what I did was I measured the shank diameter. It's 2 millimeters. Went on eBay and I found 2 millimeter carbide rods, and they're cheap. They're like $5 or something each. So I bought 4 of them or something like that. They took a few weeks to get here from China, but totally worth it. And they come this long. They need to be shortened to whatever you want. So if we pull one out, you can see it's like that. Carbide breaks very easily, so what I do is I either take it in some pliers like this, grip it, or these ones don't fit, but grip it, and then you can just break it. Obviously wear safety glasses. You could break it, or you can put it in a collet and kind of tap it and shear it off, and you get a pretty rough length. And it usually leaves about, that much of ugly section, which you can grind off, and I'll show you that in a little bit. There's kind of a cool way to do that. But from one rod you can get 3 or 4 different lengths of tip. All you have to do from there is take a metric M4 bolt and drill a hole, a 2 millimeter hole, which is 0.0787, not even all the way through, just as deep as you want, which I did to here, and then you stick the rod in and super glue it in, and you're done. Well, done for that part. And then the last part is to make the tip. And to do that, I've tried gluing the ball directly to the surface. I don't have any glues that are that strong. I know that the fancy Renishaw ones are glued in, like it's a ruby ball that's glued on, but they have some crazy industrial glue stuff that I don't know. Let's look over here. So here are ceramic balls, because I know ceramics are very round, so I thought it'd be a good idea to use the ceramic ball on the probe, but since I can't glue it straight on, my other option is to drill a small hole through it and put the rod inside. But I have no idea how to drill this kind of ceramic. It's like SIN2, something like that. It's really hard and really abrasive, and I tried it with carbide and it just tears it up. So those don't work. So I found some, I can't remember if these are steel or straight up stainless. These are 3 millimeter balls, which is the standard size, 0.118 inch. You could use whatever you want, but the Tormach is sort of designed, the programming in the Tormach machine is designed for a 3 millimeter ball, so you just stick with that. As you can see, there is a little 2 millimeter hole milled out of it, drilled out of it, whatever. So that your carbide rod will just drop right in there, and then again you super glue it and it works awesome, just like that. Okay, so let's go through this step by step. Let's make the drilled screw first. It won't take that long. Alright, so to drill the hole in the M4 screw, I've just got a piece of garbage aluminum here. I'm just going to plow a hole through it to tap it. This is a 0.129 hole, which is the drill tap size for M4. I'm going to turn it to, I don't know, 2000 RPM. Jog it down manually. Now one thing is I'm not going to move the table in X and Y. So I want the mill to be planar. Wait. Yeah, I think it matters. Yes, it does matter. Let's see here. Go over to my drill and tap drawer. I'm going to use, these are my M4. I'm going to use these really shiny ones I got from OSG. I feel like I got these from Tormach. I can't remember though. But they're definitely OSG taps, and they're spiral flute, and they look absolutely gorgeous and meaty. So I've never used these. I'm going to try them. Oftentimes I use the coated ones, like here's a regular bottoming tap. These are spiral flute, but the OSG ones just look cooler. Okay, I lied. While I don't really want to move the mill in X and Y, it's much easier for me to drill it with this guy. So I'm just going to move it like 2 inches over, and then we'll move it 2 inches back. Quick square to WD-40 just for kicks. Looking good. I'm going to make sure there's no burr on the top, so I'm just going to manually put a little chamfer there, just so that the screw goes all the way down. Alright, now I'm going to move X back to 0. Switch out my drill bit. This is a 2mm drill, or .787. I'm not going to worry about actually zeroing it off or whatever, it just takes too long. It's going into steel, so I'm going to do 2000 RPM again, I don't care. I might have actually gone through. Which I kind of don't really want to go through. But it's hard to watch the camera viewfinder while actually judging depth. But this is a quick and dirty just to show you guys what I'm doing here. No, I did not go through, so we're good. Pretty close though. Now I'll do a few more just so I have these in stock, because if you take the effort to set everything up, you don't want to have to set it all up again. So just make 5 or 10 of them. You're buying the materials for that much anyway. The screw length of these in millimeters is, these are 10 mil. I think 8 mil would work, 12 mil would work, but these are 10, so. And just to prove it, like a glove. A little tight actually, but that's fine. Fits perfect actually. I like it. Deep enough, glue will keep it plenty. You actually don't want to make it too deep because then you're just wasting carbide. This is not a very high strength application, so you don't want to make it like that deep. You're just wasting that much carbide. It doesn't matter. You can make it maybe that deep. Or that deep, just to go in the head a little bit, fill the head with glue, the screw, the hex, and then it's golden. So I used to do this job on my old lathe, before I got the Tormach lathe, because you just kind of throw it up in the 3-jaw chuck and put a drill bit in there and drill it with the tailstock. But this method on the mill is literally just as easy, just as fast, so why not? As long as you drill and tap the hole so it's aligned, then you're good to go. Now, you may be wondering, all this drilling and tapping and all this stuff, doesn't it have to be like perfectly concentric? Yes, it does, but when you're making the tip, it doesn't really matter because this is very adjustable. There's these 3 adjustment screws on the outside, and then there's tiny little set screws on the inside here for further adjustment, so you can adjust the tip to be as off-center or whatever as you want. So it doesn't matter if this is like zigzagged. In theory, as long as you can adjust it so that the tip is centered, and there's a great adjustment technique we'll get to at the end of this video. So it really doesn't matter if everything's like drilled perfectly on center and all that, because it just works. Trust me. Aha. So I just found the original tip that I'm pretty sure this is the one that came with the Tormach. I don't know if you guys can see it in the video, but it is glued on somehow to a flat end of the carbide rod. So I don't know what kind of cement or glue or whatever they use, but nothing I had could do that. I bought, a long time ago, I bought 3mm steel, chrome steel, so they're not stainless. 3mm balls from Tool Supply on eBay. He sells tons of different bearing balls. He's in Florida, fast shipping. I get stuff to Canada in like a week, which is great. No complaints at all with Tool Supply. So I got a bunch of these. I'm going to figure out how many I need to make. I want to make as many as the screws that I just drilled, plus a bunch of extra. Because, say, there's nothing that says how long the shank has to be. So say you start off this long, and when it breaks here. But there's still a lot left. So I could cut that off, I could grind it flat, and I could put this into one of the new screws and just have one that's this short. And I've done that many times. I've broken them, 3 times and just keep using a shorter section. That works fine. Here's one of my custom ones that's broken, and all I have to do is grind that flat, put the ball on, glue it on, and boom, I have another one. So I always want to have more balls and more carbide rod and more screws and just lots of stuff. Alright, so I have 6 balls plus a couple extra stubby lengths. So I don't think I need to make too many of these, but I'm going to make at least one for you guys. Maybe a couple. So on my vise here, once I take out the scrap piece, I've got some aluminum monster jaws that I've had in here forever. If you see, I don't know if you can see, there's a divot right there. That's where a long time ago when I first did this project, I basically just put a ball in there and squished it down real tight. And I'm going to do that again. I'm going to use a carbide rod just to support it so it doesn't fall down and disappear. And there it is. Doesn't have to be too tight, just snug. You can barely see it, right in the middle there. Yeah, you can barely see it. It's right here. So we are going to have to zero the center of that, or at least close enough to the center. So maybe I'll put a pointy V tool in here, a chamfer tool or something, and then just eyeball it, make the first one, see how centered it is. As I said, it does not have to be very close. Okay, now the tool that we're going to be using is my tool 12 here. Also tool 8, it's the same tool. 1/16 4-flute coated stub carbide end mill. I get these from Lakeshore. I go through tons of these. This one happens to have a flute missing, so it's broken, which is great because this is a very abrasive operation, and I blow through these. I can get many balls out of one carbide end mill, but then the carbide is dead after that. So I'm going to try this already dead one anyway, see if I can bust a couple holes for you guys, and we'll see if it lasts. So this is going to, I wrote a quick code that helically interpolates down, so it goes in a little tiny circle. An 0625 end mill in an 079 hole, so there's some room to go around. And here's my little 1/8 chamfer end mill. I'm just going to eyeball it. Put this in the spindle and eyeball it down to center. There we go. Oops. So these are technically hardened steel balls, so you are hard milling doing this operation, but don't let that scare you too much. Just do it, see what happens. I'm going to use an air blast just to keep the chips out of there, and it doesn't take very long at all. So I'm just going to, since I have tool 12 in there now, I'm going to jog it down, eyeball it, make sure it still looks good, and then hit go. That should be almost zero. Let's try it. Excellent. Well, did not expect the coolant to come on because I just forgot. Whatever. Luckily I turned it off before everything got soaked. I didn't get very wet at all. So that's good. It ran a lot longer than I remember it did. 2.5 minute run just because it's like super duper conservative as it's going down. So it goes down and then it does a couple full depth circle passes to make it to the right size. So we'll take it out and we'll see how close it is, or we'll just try to put the rod in, the soaking wet rod right now. Don't know if that's going to go in all the way. So I might have to do a little bit bigger diameter, or just look at the end mill and find that it's completely dead. But I remember last time I did it, I did like 20 of these balls with the same end mill, and it was trashed afterwards, but it did the trick. Alright, so this one is quite off-center, but that's okay. The hole's a little bit too small. I tried to pound it in, you can see the ball actually cracked apart. It cracked a chunk off, so not only was it off-center, but it was a little bit undersized, and that just broke it. Of course, I took the ball out before realizing which way, X or Y, it was off-center. So whatever, I'll just make another one and try to make it a little bit more centered next time, no big deal. Well, that was fun. So I upped the feed rate from 1.8 inches per minute to 6, just to see what would happen. I was sick of waiting for it to go down. And that moved a lot faster, and it was kind of fun to watch. Yeah, so that took 1 minute instead of 2.5, which was a lot faster. And this way I can look and see if the hole is on center and to size. I made it a tiny bit bigger. So we'll see. Ha! I accidentally tightened it a tiny bit more with the vice handle, and it shattered into a million pieces. That was fun. Alright, next I'm going to break a piece of this carbide rod just to show you guys how to do it. Just got some vice grips. It's pretty breakable, so I bet you I could just do it with my fingers here. There we go. Longer than I wanted it to be, but whatever. You can see the end of it there. That'll have to be ground off, so I'll show you guys how to do that right now. So here's our bench grinder. This literally came with our house when we moved in. Just got a crappy stone wheel on it. It's probably some aluminum oxide thing. And then, trusty cordless drill. I'm going to chuck it up like that. And then simply spin this while spinning that. Try to keep it straight and parallel to, or perpendicular to it, and grind away until there's nothing left, or until it's totally flush. Looks good to me. I did get it pretty hot, so it discolored a little bit. I was just in a rush, but shouldn't matter. Now we have a fairly perfectly ground pin. Sweetness. Alright. Okay, we got our new pin. Another thing I wanted to mention about this Tormach probe. I think it's $220 or so, maybe less or more with the arbor. But this is excellent for anybody with a Tormach personal CNC, or all of you guys with the hobby mills, you know, the Grizzlies, the IH, and the blah blah blah, all the other ones. It is a good probe for a cheap CNC operation, especially once you have replaceable tips that are very affordable. The one thing, my biggest gripe about this, aside from wishing it was wireless, is this thing. Let me show you this one. So once you pull off the bottom cover, you get this. Okay, and it's basically six ball bearings, and the thingy goes in here like this. And we'll put a probe tip in here. So that anytime it senses movement, one of the three breaks contact. And inside there are spring pins that contact each thing, so that an electrical signal goes from one to the other to the other to the other, and then back out the wires. So anytime it breaks contact between the balls, it works. These pins are garbage. They are non-magnetic, so it leads me to believe they're some sort of stainless. They're very soft, and they dent over not a very long period of time. So on the underside of them, where they contact the two ball bearings, which are undoubtedly 60 Rockwell hardened, these form little dents, and that causes the probe to stick and not trip, or to stay tripped after it touches, and it leads to problems. It's kind of stupid. So what I've done is I bought some 3mm rod, and I ground down pins. So you can see here that the one on the bottom is much shinier, this one, because that's got carbide pins in it. So all I did was I broke 3 pieces of carbide rod, and I ground them, just like I showed you guys, down to the thickness or the length of the factory ones, like so, and then shoved them in. They pull right out. You could put a drill chuck on it, pull them out, careful not to scar them up too much or anything, or you can do some pliers, just kind of be gentle with it. And then to get the new ones in, they press right in. You can glue them in if you want. It doesn't really matter. It's a really good fit. And the carbide is a lot harder, so gripping it with jaws or whatever, it doesn't really affect it. So that needs to be done, and also the spring inside. I always like to lengthen them a little bit. That prevents the probe from sticking. So the new carbide and the lengthened spring, let's see, this one is undoubtedly lengthened. Yeah, I took this to 0.73 inch. I think they're about 6.25 or 6.5 stock. So if you bring it up to about 0.75, that just gives it a little bit more strength to center itself again. Because when it sticks, it doesn't work, and I set up automatic probing routines where it goes dunk, 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 and measures every point. And if it sticks halfway through, it doesn't work. It's stupid. So those two little gripes, the spring and the carbide, make it a really good probe. And replaceable tips make it a great probe. So far we've drilled holes, we've milled holes, and we've cut carbide to length, and now it's just a matter of super gluing it all together. Easy peasy. I don't even have to show you guys that, because you just do it. You fill, like I fill the cavity with super glue, and then I just shove the thing in and let it dry. Hello. So real quick, to wrap this video up, I'm going to throw one together off camera, and then we're going to put it in the mill, and I'm going to really quick show you guys how to center it. It's a very long and involved process, and don't be afraid if it takes, or don't be surprised if it takes you over an hour to center your first one, depending on how accurate you're actually trying to get it. I like to go for near perfect accuracy, if not perfect accuracy, so it takes a long time. I'm getting much faster at it because I've done it so many times, but still, it's a commitment of time. If you want the accuracy, you spend the time to do it. So that's why I'm not going to show you guys perfect accuracy, but I'll show you how to do it. Alright, so next up, I just put a piece of aluminum in the vise, drilled a hole into it, because all you need is one circular reference location to zero your probe off of. I like to have something kind of skinny and higher up, like that is, so that you can access the adjustment screws on the thing. If I'm probing a hole just on a big fixture plate, it's kind of annoying because I have to lift up the Z every single time to access the screws. So this works. So I'm going to rotate it around. Yeah, you can easily see that it's not concentric as we set it up right now. But that's okay, super adjustable. Alright, so the easiest way is to stuff it down into the hole like I just did. And then we're going to go over to Mach 3. I have not installed PathPilot yet, and I feel very bad about that. I need to do that. I'm going to go into the XY probe screen, comp probing. This button right here will put it in the middle of the hole, but it won't zero anything. So if I click that, my feed rates, I usually go for 3. Which is nice and slow. My feed rate is 3. Click that. It's going to probe side to side. Alright. And then you got to read the Tormach manual to really understand this, but I'm just going to go through it real quick. I'm going to hit select 2 and then do the same thing. I'm going to feed this up a little bit faster to 10. Okay, so that sets that as something. 1 has to be 0. And then you click select 3, and then what you do is you rotate this exactly 180 degrees, more or less. And then you do it again. And then the control software has math to know that, well, if it's zeroed here and you rotate it and it's off, and then it knows how far off it is, but not only that, it knows how many screw turns to do in order to get it back to center. And it's not accurate, but it's close, and it'll get you ballpark pretty quickly. So now that I'm on 3, I will do it again. And then you can see the numbers are different. Negative 3 thou, negative 4 thou, that's pretty close on X. Negative 0.21, negative 0.19 on Y. That's not super close. So adjust probe from 2 to 3. Screw 1 needs to unscrew 0.02 of a turn. This is not degrees or anything. This is if 1 is a full revolution, 0.02, so 0.025 is a quarter. No, 0.25 is a quarter. So 0.02 is pretty much nothing. 0.22 is a lot, 0.24 is a lot. So I have to adjust these screws. Negative, unscrewing, positive, screwing in. And you fine tune it and keep rotating and probing until you get these numbers to read. If they read 0.02 all across, plus or minus, then they're close. 0.01 across is closer. Good enough for most people. I like to make them all read zeros, and it takes forever. But I like to feel it's worth it. So that's that. Not much else I can say without just being redundant or taking more of my time. I think I'm actually going to leave this now because in about 18 hours I'm on a flight to Blade Show. So I don't want to waste too much time on other stuff. And I have stuff to do before Blade Show. Luckily we're not crazy busy trying to finish up the last coolest knife. Eric did finish one up today, but it was sort of relaxed. Because we're not bringing anything ridiculously awesome. We're bringing some cool stuff, but nothing like one-off custom, I made this just for Blade Show kind of thing. But anyway, hopefully you learned something. Hopefully you guys running this style of probe can save some money based on that advice. And happy probing. Anyway, take care. Bye.